Good morning. Let's dim the lights. That'll be good. Question number one. Have you been able to get a textbook, the red textbook? Raise your hand if you do not have it. Do not have it. You're not able to get it yet. Do you know where to get it? Do you know where Bare Necessities bookstore is at? It's in the IC building. You with me on this adventure? Okay, so you have to go over there and get it. I have a few days that I will have printed out, but after this, then hey. Yes, that's it. Perfect. And do you know where to go get it? Yeah. Okay. So again, this is good for probably get your rest of this weekend, a little bit next week. And you also you know where to go get it? Bare Necessities bookstore in IC. Okay. This will be good probably for this week and a little bit next week. So. Anyone else? Oh, well, you're okay. You don't have to go get it. You just start bringing it each day to class, but everyone else has been able to purchase a book. Again, if you don't have the book, please get over there and get that so we can, because you're going to start doing homework out of it. And so, that's not my password. What's my password? It's 8 dots. 8 dots. Sweet. All right. So here's the nice thing. Any day that we have an official lecture, I will actually provide you with notes. Okay? So the nice thing is, you choose how you want notes to work best for you. Does that make sense? I am not going to do a notebook check. Why don't I do a notebook check? Well, because not everybody learns by having things organized in a notebook. So why am I putting a bias on those who use notebooks versus those who don't? So if you're that person saying, you know what, I got a place on my desk in my room, I'm going to put this, or I'm going to put it on the kitchen counter, and then mom's going to say, what is this? Or if you're going to put it in your locker, I mean, there's all different opportunities. But I will always provide you guys the opportunities to take notes. These can go into, I have 3 hole punched them, I've stapled them, and pretty much anything that's on here is going to be similar to the notes that are up on the board or that I have to write out. So if you notice, it says warm up, no calculator. That's the same slide. Mine is just magically projected, and yours is on black and white. So let's while I'm kind of starting off a little bit, take a look at those and maybe think about how you want to go through those types of problems. Some of them look like they're left to right. Some of them are grouped together. Some of them you have a different higher order. You should know that addition and subtraction are the same order, they're the same power, and then multiplication and division are a little bit higher. And then if things are in parentheses changes the priority of something, or square brackets. So I don't know if you ever knew this or not, but you have parentheses that look like that, and then you have these square brackets. They mean the same thing. It's just a way of grouping things. One's not a more powerful math tool than the other. It's just that's how they will use it to decipher 2 different things. So problem number 1, letter A. Would you feel okay if we were to go left to right doing this problem? Yeah. Everything seems to be about the same power, either addition or subtraction. Agreed? So you're absolutely right. So you can just go from left to right. So negative 5 plus 12 is 7. 7 minus 3 is 4, and it's done. So that's the same power. They're equal. And again, this is just warm up. This is prior knowledge. You should have this under your belt. Letter B has a set of grouping symbols. Well, the 3 outside of the grouping symbol says I need to multiply in. But the grouping symbols say, hey, do me first. So letter B, what should happen first up there? Yeah.
You do 4 minus 10, which is 6.
Is it positive or negative 6? Negative 6, yeah. Now what does that mean? Multiply. Heck yeah. Negative 18. Is that all right? Letter C incorporates division and addition. Division is a higher power. So you have to do it first in simplifying a problem. So on the letter C, I should go 8 divided by 4, which is 2, and then you're going to add that to the last 2. So come up with an answer of 4. And then letter D, looks like there's an addition problem as part of it, there's subtraction as part of it, there's multiplication, and it's also grouped. So what do you think is the very first thing we should do on letter D? Yeah. Yeah, take care of those parentheses. So 2, or negative 2 plus 5 is 3, right? And then minus 2. What kind of problems are those 3's now? Multiplication, so let's take care of that. So we get 9 minus 2, so we'll come up with 7. So you're just simplifying those. Now, I did get your quizzes graded. Some of you did well, some of you didn't do so well, some of you did in between. What does it really mean for you? Let's just, if you didn't do really, really well on it, let's keep an eye on you for a little bit. Let's have you walk through this class the best we can. And if needed, we can move you. We have one class lower than this, filling gaps, but let's just see. Maybe it was just getting into the year jitters. I gave you the 4-letter word quiz. Test is another 4-letter word. Sorry about that. So let's just kind of see where you're at. If I'm ever doing something up here and it is just so distant on what I'm doing, ask for clarification. If it's just so far gone, then maybe we might need to think about moving you to a different spot, which is okay. Because one thing I do know, it sucks to sit in the class that you're going, what is going on? I remember one time I walked into a class in high school. And unlike most students, there was a note on the door, and guess who didn't pay attention to the note on the door? Me. Why should I do that? I'm in class 307 or whatever it was. I go walking in, sit down. And all of a sudden, they're speaking German. And of course, me, I'm not the student that I probably should have been. I should have probably sat in the front row so it would have been easy to slid up. No, I'm like at the furthest end of the part of the classroom where I have to like step over people to get out. And I'm sitting there. Well, maybe they're just joking around. Came back the second day. Hello, Finn?
Hey, yeah.
Good to see you. Would that second seat right there work for you? Yeah. So I sat in this class actually for a couple of days and kind of kept moving down in my seat going, oh, no. Unless it's money, then I'll take money. So I didn't like being in the wrong class because I really felt uncomfortable, especially when the teachers up there, like, German, 17, 18. Like, these kids have been speaking German before they were born. And I'm just like, oh. Get myself out of this. And then I realized, phone calls going home because I'm missing my particular class, and my mom's like, why are you missing class? I'm like, I was there. You're absent. And then actually, I was there. Then it was figured out. Didn't you see the note on the outside the door? Switch. This is before the whole computer age, so like things had to actually be manually done. Oh, jeez, I was lost. So, anyhow, all right. So we're moving on these notes. Finn, were you able to pick up the CP Algebra 1 book?
Yeah.
Okay, so you're good. You're set. Okay, thanks. Solving linear equations, and this is solving two-step equations. And there was a part on this quiz that we did the other day that did have two-step equations on it, just to see if you could start finagling through it. If you were kind of got to those problems going, all right, I was good up to this point, but boom, it's all right, we're going to kind of learn how to do it. So when we were solving, let's put a little disclaimer in place. If we are solving for something, there's something that's always going to be on the problem. It's going to be some sort of equal sign, or a greater than or less than sign. Equal, greater, or less than. That means you're trying to get the variable, or the letter, or the symbol all by itself. If you don't have an equal sign, and it just says simplify, it doesn't matter if you have X's and Y's and J's and P's and Q's and smiley faces and palm trees and dogs that are named Scooby. It doesn't matter. You're not solving for it. You're just kind of putting things together. But if you have an equal sign, that means that it's solving. You're trying to move it through in order to get it correct. Okay, so solving two-step equations, it will have an equal sign, it'll have the greater than or less than sign, and then you have the ones that have the equals. So that's where your solving should take place. And again, that piece of paper that I gave you, you can write your notes on it, you can jot down stuff, and of course we're recording, so if you forget something, you can always go back and take a look at it. Finn real quick. I record all my lessons. They're on Schoology. You can always go back to it. And this is the class. You guys are the lucky ones. You guys get recorded. The other classes don't. Not because you're better. Well, you guys are better, but don't tell the other classes that because they just seem to get jealous and stuff. But you're recorded just to make it done early, so the kid who's sick from 5th period could actually see the video probably before 5th period. All right. Let's see. Inverse. I'm not an English teacher. What does inverse mean? I know what reverse means. That's R on my thing on my car. Opposite. Okay, so opposite. So something that maybe undoes something. So what do you think? The inverse of addition? Yeah. Subtraction. Yeah, baby. Subtraction. The inverse of subtraction must be then addition. Oh, yeah, you guys are catching on. The inverse of multiplication. Division. I like it. Dividing by a number is the same thing as multiplying by. You got that? Yeah, reciprocal. Uh-oh, now they're going to challenge me. Reciprocal means you flipped it over. How do you flip just a whole number over? Like 7. How do you flip 7 over? Let's see. Yeah. No, not negative. Yeah. No. Oh, let's take a step back. If the reciprocal is the flip over, so what would the reciprocal of 3 over 4 be? 4 over 3. Okay. So now let's go to 7. 7 is not a fraction right now, is it? 7 over 1 is. So what is the reciprocal of 7? 1 over 7. Now, does the reciprocal change the sign of our number?
Yeah.
Does it change the sign? Does it change from positive to negative? No, we didn't change any signs. I didn't say what's the reciprocal of 3/4, and you said, oh, it's negative 4/3. No, it's 4/3. So the reciprocal is just the flip over. If you're going to flip over a number, you have to put that number over 1, and then you can show it flipped over. Does anyone know the only number that doesn't have a reciprocal? 0. Anyone know why?
You can't make it a fraction.
Can't make it a fraction. Why can't you make it a fraction? You're absolutely right.
There's no absolute value.
Dude. Love this kid. There's a calc class down the hall, man. You're set, man. I love it. Yeah, so think about it. I know y'all have played on a calculator at some point in life, and maybe when you're a little kid, you might have thought it was fun pushing all the buttons and keep seeing what happens, and then all of a sudden error shows up, right? You know what I'm talking about? That error meant you probably went divided by 0 at some point. You might have hit the divide sign and hit 0 in there. All of a sudden, that's an error because you can't divide by 0. It's actually an infinite limit, and that's something that you don't even have to worry about for like 5 or 6 years. But that's if you go that far in math, if you choose to. I did, so if I can make it, you all can make it. So don't ever think that you can't make it through calculus and above. Calculus is a beautiful class, by the way. But that's what the whole divided by 0. So when we solve an equation, so if we're solving, what do we know it's going to have there? It's going to be part of it if it's solved. What's going to show up on the problem? There's 5 different signs. One of them might be a. Someone's ordering. Yeah.
Addition?
No, not addition. Solving is going to have 5 different signs. I just covered it on the last slide. Yeah.
Equal?
Equal. What else?
Greater than?
Greater than. What else?
Less than?
Less than. Last 2.
Greater than or equal to?
Greater than or equal to. That means it has the sign where you have the line under it. And then less than or equal to. So when you're solving, you're going to have one of those signs. And so when we solve an equation, our goal is to isolate the variable. Means you get the variable alone. The variable is the letter that is meant to represent a number or numbers. Cool. We're over a third done with the notes. Happy day. What time are we out of here? Like at 9:40? We're in trouble.
10:06.
Oh, we got plenty of time. All right. We good so far? Happy? Pacing okay? All right. Okay, so it says solve 3x minus 2 equals 4. And we talked about this a little bit in the precursor to the class that this is called a two-step equation because we have to do two mathematical operations in order to get our variable. What is our variable up there on example 1? X, right? But it could be anything. It could be M, it could be J, it could be a smiley face, it could be Greek letters, it could be a symbol. A variable doesn't have to be a letter. And, the further and further and further you start progression in math and science, you start realizing X is like the least used out there. They start using all these other things. And I wasn't at those meetings. So let's see. Step 1, cover up variable. What does that mean? Cover up variable. Okay. So if I cover up variable, I did that, right? So I'm not going to go 3 minus 2, right? Because the 3 has an x attached to it. Okay, step 2. I might not use this. This is, let's see. Does anyone, maybe, could you do that in your head, do you think?
Yeah.
What do you think?
X equals 2.
X equals 2? Is that right? So that would mean that 3 times 2 is 6. 6 minus 2 is 4. You're absolutely right. So just, sometimes you can just investigate these. Maybe you can go through your head and do it. So what was something I was kind of showing you with this type of equation? What color was I using then?
You were using pink. But you're going through the equal sign. And then you would.
And why am I doing that? What is it?
So you can separate both sides. So you can.
Good. Separate both sides. Go ahead.
And then for the next part, you would add 2.
You're totally right. So the reason I put that pink dotted line in there is I want you to see that there are two sides to this problem. There's a left side of the equal sign and there's a right side to it. So this just makes it easier to sometimes look at. Is it required? No. It's just something, a little thing I had seen a long time ago that said, that kind of makes sense. So it was already said that we would add 2 to both sides. So I've added 2 to both sides of the equal sign, right? So that cancels that. That leaves me 3x on this side. And that leaves me 6 on this side. Yeah. 2. How'd you get there? I mean, I know you can look at it, but you use division. Awesome. So the reason you use division is what reason?
Because it's the equal sign.
It's the equal sign, and how are 3 and x being held together right now? What's the?
It's just a variable.
It is a variable. The x is the variable. How is 3 being held to the variable? Is it being added to it, subtracted to it, divided by it, or multiplied together? Is it what?
Wait, what?
How are 3 and x being held together right there? Yeah, I know you do. I should watch this. Going to kick out right now, Michael.
There's nothing to take away the x.
Right.
Nothing to cancel it out.
So how are 3 and x being held together? Yeah.
Multiplication.
Yeah, they're being multiplied together. And so in order to do multiplication is divide is what she says. So sometimes I go, oh, don't ask the question as clear as I should. So that, if I do that, that cancels out. And that's a division. So that gives me x equals 2, which we saw in the beginning. And then if you didn't see in the beginning, as we progressed through this problem, you started realizing that's why it's 2. Okay? How do you know if our answer's right? Well, our original problem was this. You agree? Which means 3 times 2 minus 4. Is that equal to 4? Well, that's 6. Oh, that's a 2 right there. See, I'm making up stuff as I go along. I'm just out of control these days. So is 6 subtracting 2 equal to 4?
Yes.
Yeah, that tells us that this is indeed our solution to the problem. Now, let's go on a real basic idea of what this the math behind this you had used for a long time in life. Okay? I know most of you have probably used a key to unlock a door. Maybe right now we don't go that way. Okay? Most of you have some sort of cell phone device that has some password protection on it, right? So basically what you're plugging into for your password is your solution to the problem. And so your solution might be your birth date, your address, your favorite number sequence, I mean all kinds of things. But it's something that your device at the time allows you to choose. So this is the solution. The math behind it is really what you use it every day. It's like, oh wait, my key is the solution to this lock. If your key's not the solution to the lock doesn't unlock. You put the wrong passcode in on your phone. Some of them, and I don't know a whole lot about technology, but things that I have realized is sometimes you try and plug in a passcode so many times and then it locks out a person for a certain amount of time. Am I right? Because I thought that was funny. A friend of mine, I was down in Arizona, he had left his phone at the table and he was using the restroom. And so I was trying to hack his thing because I thought it would be funny to play a joke on him, but it locked. And it wouldn't allow me. So I kind of put it back. And he kept thinking, man, where's my phone? I can't get into it. I was wrong. I was just looking over there. Look at that game on the TV. So, yeah, that was Scott. He's a good guy. He's a fireman now. So he's enjoying his job. All right. I'm not going to really worry about these steps right now. I kind of like the way I'm going through it. So if I did the 12 equals y over 3 plus 3, what would my very first step be? What would I feel comfortable with? Go ahead.
You add 3 to the other side and subtract 3.
Okay. Before that, yeah?
Subtract 12 to both sides.
I could do that too, but before that, yeah?
You subtract 3 for both sides.
I could do that, but before that,
Divide by 3.
I could.
For
Now
the y over 3.
It's
Or is that?
you'd have to multiply there, but before that, yeah?
you have to do is cancel out each other.
Nope, because one of them's being added, one's being divided, yeah?
Flip the reciprocal.
No, yeah? The very first thing. Very first thing.
Draw the line.
Yeah, pick line.
You don't have to use it.
No, you don't have to, but it's just that's how I'm going to go about it. That helps me because, I mean, you've already seen me teach. I'm making errors left and right, so I got to have all the help I can get up here. So I have a left side. On the left side, I have 12, and on the right side, I have to have y over 3 plus 3. So some things that were asked, could I add those 3's cancel each other out? They could if this 3 was up here, but it's not. So these can't cancel because this is just being added, and this is division. And division and addition don't mix together. They're different orders of math. So I want to get y all alone. So I had heard, someone had said you could subtract 12, which would have put a 0 over here. I don't know if we have to go that way. So I think I know what some of the hands are going to say. They're going to say, hey, I'm going to do this to both sides. Is that okay? So that means once I have my answers done, I'm going to have the variable, the letter y, actually on the right side. Do you think that's okay?
Yeah.
Absolutely. Okay, so we're going to do this. This cancels that. 12 subtracting 3 is how much? 9. 9. Yeah, we can do that all day long. And then I get y over 3 still. Now, how in this case, this number is not next to the letter to multiply. This letter is underneath it. So that looks like a fraction. And a fraction's a sneaky way of doing what math operation? I heard it. Division, yeah. So what undoes division? Multiplication, absolutely. So I'm going to multiply this by 3 and this by 3. So that cancels that. Agree? 3 times 9 is 27. 27 is equal to y. Okay, I'm happy if you leave that answer just like that. I just need to warn you, sometimes other teachers, or if it's multiple choice, we would actually have the answer written like this. I feel they're both the exact same thing. I understand them like either way. So you choose which way you want to do. If you're done with 27 equals y, because you're like, dude, I can't write anymore. Okay, I know writing y equals 27 is a strain usually, but I get it. What do you think would happen if I were to plug 27 back in?
It would all work.
It would all work? What does that mean? It would equal to 12. You nailed it. If I plug 27 into that, I get 27 divided by 3, which is 9. 9 added to 3 is 12. 12 is equal to 12. Boom. That's the key to unlock the door. That's the solution to the problem. All right. You got a couple to practice. So why don't you practice those, which are on your paper, and I will have, excuse me, I will have them worked out for you in a moment. So why don't you just work on yourself? If you get stuck, please by all means look up here. But I'm just going to work each of these out as you're working them on your own. And if you're feeling comfortable about it, so the first one's done. If you're done with yours, then look up there and double check it. Second one's done. Let's see how you all are doing. And the side of the paper that has the lines on it, you can write there. That's yours. You can write anywhere on there you like. Yeah. See? All right. Yeah, buddy. Yes. Coming to you. Right, because that's a positive. All right. as you're progressing through, see how you're doing. On that last one, I have a question mark towards the last step. So I have a question mark on purpose because it's a different concept. I just want to make sure we can all see it together. Is everyone up to number 6 at this point? Anyone need more time getting up there? Okay. Just be another minute or so. Yeah. I'm meeting with my group tomorrow. We're going to talk about it in the class next week. All right, if you're not quite done, that's okay. But let's take a look at number 6. By looking at number 6, does everyone feel comfortable adding 4 to both sides as the first step? Then we get where we have 2/3 m is equal to 6. Correct? So a fraction times the variable is equal to 6. So that's saying 2/3 of what number gives me 6? And I have no idea. I can't do it in my head. So you guys probably can. You're a lot smarter than I am. But, I cannot. Let's do this. Let's see if you recognize what I do here. I'm going to multiply by 3/2. 3/2 is the what? Reciprocal. Good. So if you multiply by the reciprocal, this 3 cancels that 3. This 2 cancels that 2. That leaves me m. Then I have 6 times 3, that's 18/2. And 18/2 is how much? 9. So our answer is m is equal to 9. So sometimes part of this, if you have a fraction that's tagged to a variable, now a fraction can be in the problem where it's just being added or subtracted. But if it's next to the variable, how you undo it is you multiply by the reciprocal of that fraction, so to flip over that fraction, okay? How does this all feel? Is it brand spanking new, or is it like, whoa, wait a minute? Or, dude, you're going way too slow for me. I'm going way too slow for you, I'm sorry. May I move to the last slide, or is there any questions on these? Good? All right, yeah.
For number 4.
Number 4, yes.
What do you think the negative 4?
All right, so I'm adding 4 to 2/3, so I'm going to have to do the opposite of that. So I'm going to go subtract 4. So because that's plus 4, I got minus 4, so minus 4 there. Those cancel. That leaves me 2/3 on this side. I go 1 minus 4, I get negative 3, because that's what I had to move over. Is that okay? And then on that one, you would just multiply by 3, because that's division, so multiplication undoes it. So 3 times negative 3 is negative 9. Okay. Cool? All right. Oh, man, it's not fair when they give us food problems. At Yummy Yogurt, I don't know where Yummy Yogurt's at. I'd go. You pay, what is $0.0.35? What does that mean?
35 cents.
35 cents, yeah, that's right. For a container, and then 40 cents per ounce of yogurt toppings. So you have to pay for your container first, and then you pay 40 cents per ounce for toppings. So if you just walked in the door and you just grabbed a cup saying, hey, can I have a cup? How much are they charging you? 35 cents. Doesn't matter if there's yogurt in or not. You're in the door, you took the cup, you owe them 35 cents. You just bought a yogurt for $4.75. So what's going to indicate how our price goes up? 35 cents is the cup.
40 cents.
What do you mean 40 cents? What 40 cents for what?
I'll take it.
For every ounce of yogurt. An ounce is a unit of measure. So you go in and you're like, dude, got my cup. All right, I already got you for 35 cents.
So
Okay, I don't want to put anything in it. You owe me 35 cents. Now, if you put something in it, the more you put in that cup, the more they're going to charge you. Does that make sense to say that? So let's call our variable y for yogurt. Yeah.
So basically, we just keep on adding 40, so it'd just be 11.
Is that what it is? Let's see.
It'd be 11.
So-
ounces of
So how much are they charging us no matter what?
40.
35 cents. That's our constant. Our constant that's going to take place is 0.35. Okay? And we spent $4.75 on this yogurt. So do you all feel comfortable that you bought more than the cup?
Yeah.
Does that make sense if I state that? We bought more than the cup. We put something in there that gave us some amount. So how much do we pay for every ounce? 40 cents. So 0.40 times y, because y indicates yogurt, that's what we're purchasing. 35, that's our constant. Okay, you just walk in the door, grab a cup, 35 cents. You start putting yogurt into that cup, we're going to charge you 40 cents for every ounce that goes into that cup. Okay, so how could we solve this problem? Yeah,
We can we could subtract 35
yeah.
from both sides.
So let's subtract 0.35 from either side. Everyone still with me? Because that's our original problem, so I'm going to cancel that and that. That gives me 0.40y equals 4.4? Sweet. And if we divide each side by 0.40 and 0.40, we need a calculator. Anyone got a calculator? It's a what?
It's 11.
It just comes to 11?
Yeah.
So what did we buy in the context of this problem? 11 ounces of yogurt. So I purchased 11 ounces of the yogurt. I don't know, is 11 ounces of yogurt a lot? I have no idea. I bet you nickel I'd have no problem eating 11 ounces of yogurt. That's just my opinion. But I don't know. Yeah.
Couldn't you just say without doing the two-step equations that you just say $4.75 minus 35 cents would equal $4.40, and you would just divide 4.4, and divide 4.4 by 0.4, and
Yeah.
then you get your answer.
So you used some critical thinking right there. That's a beautiful thing. Your mind saw that real quick, and I like that. That's a good way your mind works, so keep it up. Everyone might not see it that way, but that's okay. You know what's beautiful about everyone's mind in here? Everyone thinks a little bit different. If we all thought the same, we would be boring people. I think we'd be like ants, just following each other. Like, oh. Man, we're cool. We are cool as a species, in my opinion, because we're all a little bit different. You have got to praise and love people for who they are and for the differences that we all share and that we can share. I think that's pretty cool. So, I would like. I think we are on our assignment for tonight. It's page 1 in your notebook. It's the why did the muffler. I'm not going to write the whole thing. Sorry about that. Why did the muffler? So, quick question before we go. We still have a few minutes. If this was your worksheet for tomorrow, you have your name up here, right? And then your problem's worked out. What am I going to do very first thing tomorrow? Yeah. Mark where? Hopefully at the top. So if I mark at the top, that means that it looks like you did 3/4 to all of it. You attempted it. If I mark in the middle, it looks like you did between half and 3/4. If I mark on the bottom, that means you did less than half. Okay? So you want the top mark, that gets you the most points. The top mark can get you up to 4 points, the middle mark gets you up to 3 points, the bottom mark gets you up to 2 points. Okay? So, attempt it all, and then what else am I asking you to do when you first come in? Yeah? Go ahead. What did I want up on, say that board right there? Yeah. If you have a question about a problem. So if you didn't know how to do number 5, you come in tomorrow and you'd put 12c plus 6c equals 36 up on the board, and we'll make sure we work it out. Yeah. Probably next week. Yeah.
Wait, so that's like your grading right there, wherever the point is your grade, and we're doing page 1.
Do what?
And we're doing page 1 of Algebra.
Yep, page 1. It says why did the muffler quit the car business is the one. So it is page 1. It doesn't have a back to it either. So that's, or if it did have a back, mine didn't copy. Yeah. You won't be. You got it. You got it. I'm sorry. I totally forgot it. I will have it tomorrow. I was kind of rushed this morning. Not because of you, I was rushed because of all these other things. Guys and girls, I hope you have a wonderful